Alright, so let's go ahead and continue our review sheet. We're on to number 9. So for the f of the absolute value of x, what you want to do is you want to delete the graph on the left, then replace with a reflection. So literally, you are going to get rid of all of this. So you're going to get rid of that. That's going to not exist. Okay? So that's gone. And then what you want to do is you want to reflect this onto the other side. So that leaves you with a point at 5, 1, and then reflect on the other side would be negative 5, 1. And then of course the same point here, and then you're going to reflect that. So from here to here, that's your original, and then reflecting would look like that. When you do the absolute value of the function, you want to take what's below and reflect it above. So what that looks like is you are literally going to take the points that are below the axis. So you're going to take this point here, which is 1, 2, negative 4, negative 4, and you are going to reflect it on the x-axis, which that then makes the y value positive. So now you have negative 4, 4, and then you have your other points still. Notice that you now create a point here on the axis, which is about here, and you still have negative 2, 3, 0, 0, and 5, 1. So it's going to jump down here, bounce back up, go to 0, 0, and then, oops, try that again, bounce down, and then back up here. Okay. For discontinuity, this is removable or point discontinuity. You now want the limit from each side, and that looks like it's about 2.5. So the limit as x approaches 2.5 from the right, the function, the range value of the function. So as I go here, it's still at about 2.5. From the other direction, as you approach the x value of 2.5 from the left, the function is still approaching the same value of 2.5. And that should be the case because it is point discontinuity. Then the actual value of 2.5 does not exist. Oops, I meant to put 2.5 there. So DNE does not exist. Now, discontinuity here is at 0, and it is infinite. So you want to do the limit as x approaches the point of discontinuity, which is 0, from the right. The function approaching from the right is going to positive infinity. Same from the left. So the limit as x approaches 0 from the left, the function is going to, again, positive infinity. The actual value at 0, again, does not exist. Finally, you have jump. And you want to do the limit. Where's your point discontinuity? It's at x equals negative 1. So the limit as x approaches negative 1 from the right, the value of the function is approaching negative 1. I'm sorry, excuse me. Just had to close that email, got sidetracked. The range value of the function is approaching 3. Now as x approaches negative 1 from the left, the value of the function is approaching 1. But the actual value of the function is right here. So f of negative 1 is actually equal to positive 1, the range value. Last but not least, describe each transformation. This too is going to be a vertical stretch by a factor of 2. It's also going to be a horizontal translation, 1 unit. Since it's minus inside, it's the opposite. You'd think it goes left, but it actually goes right. Lastly, you have to rewrite this in standard form. So I can rewrite this as x divided by 2. Because I just do half of x, so x over 2 plus 1. So now you can see that it is a horizontal stretch by a factor of 2, and it is also a vertical translation, 1 unit up. Okay? Again, if you have any questions, please see me. If there are any questions, I also suggest that you use the test review and both formative assessments to study for your summative. As far as your textbook is concerned, from your new textbook that we just got in class, this is sections 1.2, 1.3, 1.4, 1.5, and 1.6. Okay. We also had an instructional guide lesson on limits. Okay? Good luck studying.